Everyone, so now today we're going to be doing the chapter 1.5 physics quiz level M. So this one's really easy. We just need to memorize a few formulas. So the specific heat capacity for copper is this, and the temperature of 1 kilogram is raised by a heater marked 2 amperes and 12 volts. Here in 300 seconds they want the temperature that the sample will rise, so delta T. We know that we have two formulas that we need to use for this equation. First being that Q equals mc delta T. Second being that Q equals IVT. What you do in this case, since you don't have Q and delta T, you can't use this Q. We need to find it from IVT. I is amperes or current, V is voltage, and T is time. So here we have 2 amperes, 12 volts, and 300 seconds. So you do 2 times 12 times 300. And then you get, let's see what we get on our calculators. So you get 7,200. This is your Q, okay? Okay, guys? So now 7,200 is Q. So 7,200 is equal, mass is 1 kilogram. Delta C is our specific heat capacity, which is 380 joules per kilogram Kelvin. Then we want to find delta T. That's unknown. So what you do is 7,200 divided 380. You're finding delta T. You're going to find it on your calculator equals to 18.947 something. We want it to the nearest integer, meaning round up this. It's gonna become 19. That's it. Let's move on. Okay. So here you have 50 grams of ice cubes and they're immersed in 0.80 kilograms of liquid water at this temperature, okay? So given the specific heat capacity of water is this and that the heat of fusion of ice is this, the energy needed to melt the ice cubes completely. When you see the word melt, you need to apply this formula. It's Q equals mass times LE, which means the latent heat of fusion. LE is latent heat of fusion. So mass has to always be in kilograms. So this is 50 times 10 power negative 3 to make it kilograms. Or if you want 0.05, same thing. Then you multiply it by 3.4 times 10 power 5. Once you do this in your calculators, you're gonna get your answer to be 17,000, which is 17 kilojoules. You need to convert it. Now the temperature of the resulting liquid. Okay, so here they're asking us the resulting liquid. They told us we're immersed into this much water. We need to find, and its initial temperature was 20. Its final temperature, my bad, is 27. They need us to find so you do 17,000 divide by, because you're doing Q equals mc delta T. Okay, so we have Q, so now we need to find delta T. Divide by M times C. What's M? 0.8 times delta C, or C, which is 4.2 times 10 power 3. You're gonna get equal to 5. And then you take this 5, because this is you need to do big temperature minus small temperature equals delta T. That's what our teacher told us. So we do 27 minus small temperature equals 5. It's 5 and a fraction. So once you do, like, if you're gonna do 27 minus this, you're gonna get 21.9. I don't know why they didn't round up here. Now I heard from a student or two that there is a different way of solving this. I'm gonna re-ask that student or Tariq to explain it to me so I can re-explain the second way how you get it, and I'll make a separate video on this question alone. But that's how I solved it for now. Okay, by the way, these questions are the exact same that came in the AMS quiz, so these aren't the first time we're seeing these. So let's see. You have 0.2 kgs of ice being heated by this electric heater, and this is the temperature versus time. Again, you need to use Q equals mc delta T, and Q equals Vi or IVT. So first question was asking us how much time does it take to melt or something like that. Yeah, to melt. So for that you need to go to your melting point, which is 0 degrees Celsius. You're gonna take it down. Look at the time, which is 140. Okay, that's your time. So now we have our time, and we have our I, and we have our V. I is 2.5 times 12 times 140 in your calculators. It's equal to 4,200. Okay, that's your Q. Now we take this Q and we substitute it in this equation. So 4200 equals mass, which is 0.2 kilograms, times C. They told us C down, didn't they? Wait, let me find the C without removing the solving. Oh no, actually wait, they're finding C, sorry, they want C. So times C times delta T. What's delta T here? It's the distance between 0 and 10. You just find this distance positively. So here it's 10. And once we divide 4,200 divide by 2, you're gonna get that C equals to 2,100. This isn't a 4, it's 2100, okay? They wanted it in kilojoules, I think, or kilo something. So then we move it back 3 spaces and you get your answer to 2.1 times 10 power 3. Let's see. Yep, they wanted it in joules per kilogram Kelvin, which is 2.1. Okay, so you have a 200-gram sample of ice being heated by an electric heater, and the graphs of the sample's temperature versus time is shown below. So look, the energy to melt 200 grams of ice, you're gonna need the most temperature for that, because you need to make it reach 0 degrees Celsius, from negative 10 to 0, to make it melt the 200 degrees of ice. But now between to heat 200 grams of water and to heat 200 grams of ice, it's different, because look, by 1 degree Celsius. So if you're moving this is 1 degree Celsius, and here this is 1 degree Celsius. I don't know if you can tell, the distance here is way larger than the distance here. This is really tiny. This is of ice and this is of water. So the one to heat water here is, wait, is it bigger or smaller? I can't tell. It's way bigger. Sorry. Because look, I don't know if I can show you this. Look at this distance here. It's steeper also. This is the little distance we have, and this is the distance we have here. It's gonna take you more energy to heat the water than the ice. So yeah, just know the hotter the thing is, the more energy you're gonna need to heat it. Like ice needs less energy to heat than water, but melting needs the most energy because you're moving it on the most temperature. But the specific heat capacity of ice is 2.1 times 10 power 3. Then the power rate is, so look, we have C equals 2.1 times 10 power 3. They want watts, or the power. So we know power equals to IV. and that Q equals IVT. So what we need to do here is we need to find Q first. So Q equals MC delta T, because we have here the MC and the delta T. MC and delta T. Okay? Our M, 200 grams, aka 0.2 kilograms. C, given 2.1 times 10 power 3 times delta T. Delta T, just look from the 0 point to this temperature, which is melting ice. This here is 50 degrees. So it's just, or like delta T, wait, sorry, my bad. Delta T is between this distance here, 10 and 0, so it's times 10. When you solve this on your calculators, let's solve 0.2 times 2.1 times 10 power 3 times 10 is 4,200. Okay? This is our Q. Now, when we want to find IV, how do you find IV? Because if our equation is Q equals IVT, right? And you have Q and you have T. How do you find IV only? You need to remove the T and put it on the other side. So you cancel T from this side by dividing by T, and you put it here. So QT equals IV. So our Q is 4,200. Our T is the time it took, which is this distance here, 50 seconds. So you do 4,200 divide by 50. You're gonna get IV, or aka power, equals to 84. And that's it. Here they're asking us the boiling point. So we know the boiling point is the point where temperature, or whenever you see us start getting flat, because this is ethanol, not water. I would say 800 degrees, but it's ethanol. We know that now, that since this is the flat plateau thing, our melting, or our boiling point of ethanol is 75 degrees Celsius. So now they want the specific heat capacity. Okay. So what we need to do here is Q equals MC delta T. So our M, 0.1 times our C is what we're trying to find, times delta T. Now look, we don't have delta T, right? But we know that you need exactly 340 seconds, and that we do have delta T actually, because look, if this is 75 and this is 10, the delta T is the distance between them, or whatever the number is between them, so 65. But now you're gonna say, oh, we don't have Q. We do have Q, because they told us it's a 50 watt heater. What did we just say? Power times time gives you Q, because 50 watts is 50 IV. So if you have 50 watts, just multiply it by the time. So 50 times 340 is gonna be 17,000. Now we have everything we need to find it. So 17,000 divided 0.1, or well, it's divided 0.1 times 65 is gonna be C equals 2615 point whatever. They want it in kilojoules. So you need to just tick, 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 and then you have your answer, 2.6. Most likely in the exam they're gonna, they told us two significant figures, so 2.6. Okay. So after the temperature, okay, this is the question that we made a whole fuss about in the exam. It's really easy and the answer is very straightforward and clear. After the temperature in the room drops from this, all useless because it's there to confuse you. 50 grams of water vapor condenses into a liquid. Since it's condensing, we only need the specific heat of vaporization and the mass, because we know that it's Q equals m times LV, vaporization. So mass 50 grams, aka 0.05 times 2400 gives you 120 kilojoules. Okay, that's all we do. You don't have to add anything. This is the right method. I asked my teacher and others. Okay, so look, when you have a graph like this, while it's a plateau, while it's a slope, you're heating. When it actually reaches a flat line, you're either melting or boiling. So here it's melting, here it's heating. First one is always gonna be a solid, second one is always gonna be a liquid. So yeah. And now we have boiling here at the last point. So that's it. If you added one more, then it would be heating a vapor and condensing. Okay, this question is really creative. So the human hair can absorb 20% of its own mass in water. And the mass of a human hair is this. The latent heat of vaporization is this. So the maximum mass of water absorbed by the hair of a typical person after leaving the shower. So if it can absorb 20% of its own mass. So let's see, 0.80, you need to do 0.80 times 20% on your calculator to get this. Times 20% equals, you're gonna get that's equal to 0.16. So that's your new mass. And now you need the amount of heat you need to evaporate it. So you're gonna use Q equals mLV, right? But we need to be careful here. This is in kilojoules and this is in megajoules. We need to convert this. From mega is 10 power 6, kilo is 10 power 3. So from megajoules to kilojoules, you need to multiply by 10 power 3. So 2.2 times 10 power 3 times the mass, which is 0.16. You're gonna get your answer to be 352. And that's it. It's a creative question. It's nice though. Let's move on. Okay, yeah, this one I mistyped it when I typed it. 70 grams of steel, specific heat 20 to 80, so your delta T is 60. 70 grams is 70 times 10 power 3 or 0.07 times 10 power negative 3. I'm putting in my calculator, so 70 times 10 power negative 3 times 385. So it's Q equals MCT, by the way, if you didn't figure it out by now. So times 385 times 60, you're gonna get 1617. You want this in kilojoules because this is in joules, so you need to divide by 3, so 1.6 kilojoules. That's it. Phase change. Whenever you see the word phase change, you look at the flat line. Started at 2 and ended at 8, so that's your answer, 2 and 8. Now let's move on. Boiling point of mercury is 357 and its latent heat of vaporization is this. At 357, so we know it's vaporizing, okay? You need, and this is the mass, so this is our formula. 0.15 times 300 is 45. Now let's move on. Which of the following best describes evaporation? Evaporation occurs at any temperature. Yes, it does. Evaporation causes the temperature of liquid to rise. No. How can I describe this? It causes it to drop, by the way. You know when you sweat, it will get off your body because the sun's gonna evaporate it, right? After the sweat and it evaporates, don't you feel colder? Your body will feel colder than if it was just you and the sun. That's why it drops. Evaporation occurs at boiling point only. No, we said at any temperature. But when it is at boiling point, evaporation will take place on anywhere within the body of the liquid. At any temperature, evaporation only occurs off the surface. But what boiling point, it will occur from inside also, not only off the surface, okay? That's the difference. The energy required to raise 1 kilogram of a substance by 1 degree Celsius is the specific heat capacity. Memorize it. Our last question. That's easy. See, solid to liquid, or when you see the word melting, it's fusion. Liquid to gas, or when you see the word evaporating, it's vaporization. That's it. Hope you understood, everyone. It's really easy. Hope you do good in your finals. Bye.